Welcome to ISCW Lab Number 3. In ISCW Lab Number 3, we're going to revisit SDM, Cisco's Security Device Manager that we were introduced to back in ISCW Lab Number 2. In Lab Number 2, you might recall we used SDM to set up an IPsec VPN. Now we're going to learn how we can use SDM to secure our Cisco routers. Here are the specific goals we have for this lab. First of all, we're going to telnet into a router that we have, and we're going to observe that we are allowed to telnet in, and we're going to take a look at the running configuration. Then we're going to run a process called one-step lockdown. This is a process that we can execute from within the SDM interface. We're going to configure one-step lockdown, and then we're going to try to connect to the router using a telnet session once again. This time, we will notice that we are denied. And that's because our telnet traffic is unsecured. An attacker could capture those packets and view information such as password information within those packets. We're going to learn that after one-step lockdown, we need to connect using an SSH, a secure shell client. And we'll do that. We will connect using an application called PuTTY, and then we will view the router's configuration after the one-step lockdown. And while the one-step lockdown applies many different Cisco best practices to secure our router, we want to take things a step further. We want to then use our SDM interface to configure IPS, the Intrusion Prevention System. And as we go through the lab, we will talk a bit more about what IPS can do for us, and then we're going to take a look at the configuration after IPS has been configured. But let's begin by taking a look at the topology we're going to be working with. Let's say that we are going to be configuring router R4 in this topology. We're going to be configuring this from a PC. Notice the PC that's running SDM, the Cisco Security Device Manager. It sits at the far side of an untrusted network from router R4. We're going to be connecting into router R4, in other words, through an untrusted network. And the first thing we're going to do is we're going to apply one-step lockdown, which takes a bunch of security best practices from Cisco and applies them to this router without us having to go into iOS and configure these line by line by line. It is a tremendous time saver. But to begin with, let's go out and take a look at the configuration on R4 prior to the one-step lockdown. Let's begin by telnetting over to router R4, and let's do so from the PC that's separated from R4 by that untrusted network. We're going to use the Microsoft Telnet client, and we can say that we want to open IP address 10.3.3.2. Once we connect, we log in with a username of Kevin and a password of Cisco. You might recall back in ISCW Lab Number 2, we talked about how to set up a privileged level account like this using the username command. After we get logged in, let's take a look at the running configuration. Let's see if we have any security features enabled on this router. It's interesting to note that we do have the advanced security feature set as part of the iOS release. Also notice that we have a self-signed certificate configured. That's because this router is using HTTPS, secure HTTP in other words. Something else that I'd like you to note is that we connected via Telnet into one of the VTY, one of the virtual terminal ports, VTY 0 through 4. That was permitted using the Telnet protocol, but that's a little disturbing because Telnet is not secure. Telnet is not a secure way of sending traffic across the network, because if it were intercepted by an attacker, that attacker could play back the captured packets and recover information such as password information. Let's now go in and further harden this router using some Cisco security best practices. And the way we're going to do this is by using Cisco's SDM, the Security Device Manager interface. This is something we were introduced to, by the way, back in ISCW Lab Number 2, when we set up an IPsec virtual private network. Now, however, let's go under the Configure option for SDM. And what we want to specifically configure, as opposed to the VPN configuration we did previously, in this instance, we want to configure a security audit. Let's take a look at these security audit options. Notice we have a security audit and a one-step lockdown option. Let me move the SDM window just a bit so we can better see what's going on. Under the one-step lockdown option, we are told that the SDM security audit feature can apply several different Cisco best practice security settings to iOS for us. Let's click on one-step lockdown to initiate this process. We then get a warning message saying that this is going to apply several different lines to our configuration, and we can come back to this wizard and say that we want to undo the security configurations at a later time, or we could go in and do some additional tasks. We could go in and manually take out or manually adjust these lines. But let's go ahead and have one-step lockdown go about its business. Take a look at our router's configuration, make some recommendations. Notice it's going to recommend that various services be disabled, such as the finger service that tells us who is logged into a device. Another best practice is to disable CDP, the Cisco Discovery Protocol. That could prevent a neighboring device, maybe not under our administration, from learning about this particular router. Ceph, we should enable that for performance reasons. For legal reasons, we might want to set a banner to warn people not to connect unless they are authorized. SNMP, let's disable that. That could be a security hole for us. You see, on and on, we have all of these security best practices that would honestly take us a very long time to configure ourselves. AAA, we're going to enable that as well. Let's go ahead and deliver this to the router, and before it's delivered, I have it set up so that we can view the recommended configuration before it's delivered to the router. We see the AAA configuration. I also saw a line saying that we're going to support secure shell connectivity. More on that in just a few moments. But notice all the various servers that are being enabled. Here we have our banner saying, we want you to disconnect immediately if you're not an authorized user. Well, everything is looking fine to me in this configuration. Let's go ahead and apply this to the router. We can do so by clicking the Deliver button. And there is also an option to say, we could save this configuration, the running configuration, after it's delivered to the router's startup configuration. Let's just go ahead and deliver it, however. Let's not worry about saving it. It's applying 68 commands to the iOS. Think of the time that we're saving by doing this. 68 commands, they have now been applied. We can go ahead and click OK at this point. And what we would like to do now that we have delivered these commands to the router, let's go back out and do what we did at the beginning of this lab. Let's attempt to telnet to this router. Let's go back out to our Microsoft Telnet client, and once again, let's say that we want to open an IP address of 10.3.3.2. Interestingly, this time we're denied. We could not open a connection to the host on port 23. That's the Telnet port. Remember we spoke of Telnet being unsecure? Well, what we're going to do this time, we're going to use a different application. We're going to connect securely using SSH, Secure Shell. And one of the popular applications that acts as an SSH, a Secure Shell terminal emulator, is called PuTTY. Let's go ahead and launch the PuTTY application to securely connect to this router. By using SSH, we are preventing an attacker from capturing packets from this session and then using those packets to possibly gain information such as password information. In our PuTTY configuration screen, let's specify the IP address of 10.3.3.2 that we wish to connect to, and we want to go ahead and open. And when we do this, a message pops up warning us, potential security breach. We're being given a warning about this. Remember that we're connecting to a router that has a self-signed certificate. This has not been authenticated by any sort of certificate authority. Let's go ahead and click OK, and now we connect to our router via PuTTY. We want to log in as the user Kevin, as we did before, with the password of Cisco. We are now securely and remotely connecting into this router. Once again, let's take a look at the running configuration to see what has changed since we initially looked at the configuration. Notice we have various services enabled. TCP keep alives in, TCP keep alives out. We have password encryption, sequence numbers for logging, just on and on. The number of security best practices that have been applied to this router. But let's try to answer the question, why did we not successfully attach via Telnet? Let's take a look at our VTY, the virtual TTY connections, and notice it says Transport Input SSH, Secure Shell. We tried to Telnet in. SSH, however, has been specified as the only valid transport mechanism that is worthy of opening up a session on this router. That's the reason Telnet was denied, to further secure remote access to this router and prevent an attacker from capturing packets from the network and then from those captured packets gathering information such as password information. Something else we would like to do at this point, however, to further secure our router is to apply IPS. IPS is Cisco's intrusion prevention system. You might have heard of IDS before, the intrusion detection system, which is going to detect and then shut down attacks. Well, intrusion prevention is an inline mechanism that we can configure from within our SDM interface. IPS, inline, can recognize the signature of well-known attacks and then either alert us about those attacks, drop packets from those attacks, maybe reset the TCP connection with the remote host that is initiating the attacks. Let's say we want to configure intrusion prevention. That's what we want to set up using SDM. Let's say that we want to launch the IPS rule wizard, and it says that SDEE notification is not enabled. Well, we need to enable that in order for IPS to work, so we're going to say that, yes, we want to go ahead and enable SDEE. And SDEE, that stands for Security Device Event Exchange. SDEE, that's a protocol that's being used to send messages between our IPS client and servers. And at this point, we get a message saying that SDM will open a subscription with the router to get those SDEE events. Let's click on OK, and now we're in the IPS Policies Wizard. Let's click on Next to continue, and we can specify which interfaces we want the intrusion prevention system applied to. We can select a specific interface and also select an inbound or outbound direction on that interface. In our example, let's use Fast Ethernet 0/1 and select the inbound direction that we want to apply IPS to. We click on Next, and now we're asked to specify the location of our signature definition file, an SDF file. A signature definition file is a list of well-known signatures of attacks. Let's go ahead and click on Add and say that we want to add a signature definition file. And what we're going to be doing in this lab, by the way, is a little bit different than Cisco's best practice. Cisco gives us a signature definition file as part of SDM, as part of the Security Device Manager. And it depends on how much RAM we have in our router as to how many signatures the local flash-based SDF file is going to recognize. We have 128 meg of RAM inside of our router. This 128 meg of RAM is going to give us a signature recognition capability of about 300 different signatures. If we had a router with only 64 meg or less, we would only be able to recognize about 82 different signatures. And if we had 256 meg of RAM, we could recognize on the order of about 500 different signatures internally. Let's select the 128 MB.SDF. In other words, this router has 128 megabytes of RAM. We want to use the signature definition file that got loaded into this router because of how much memory it had on board. Again, not Cisco's best practice. Cisco recommends that we instead point to an external signature server that can possibly more readily be updated and hold a larger database of signatures. But for our purposes, we're just going to use the internal SDF file. We click on Next and Finish. And before the commands are applied to the router, we get a preview of what they look like. Not as many commands here as we had with the one-step lockdown. We are pointing to a local location. In Flash, we have a 128 MB.SDF file. Everything is looking good. I think we're ready to deliver this to the router. So let's go ahead and click on Deliver. And notice we also have the option of saying that we could save the running config to the startup config. I didn't choose to do that at this point, but certainly something you could do in the real world. This time we're only submitting 11 commands, far fewer than we submitted earlier when we were configuring our one-step lockdown process. It takes several seconds for the delivery process to complete. Looks like we're done now. Let's go ahead and click on OK, now that we have delivered this configuration to the router. And it takes a few moments for these signatures to be loaded from this signature file. And if we're curious as to what these signatures are, exactly what type of attacks are we recognizing, we can click on Signatures to get a comprehensive listing and see what we're going to do in response to matching these various signatures. And notice all of the signatures in this database that we have. Let me reposition our SDM interface so that we can get a better view. But take a look at the plethora of signatures that our router is now able to recognize. And we can say we want to send an alarm to the console. We could drop a packet that's matching the signature, or we could reset the connection to the source device that's sending us this traffic that is matching the signature. It just goes on, an amazing list of signatures, and this is just with the local database. We get a more comprehensive list if we point to an external database. Let's review where we've been in this lab. In iscw lab number 3, we went back once again to SDM, the Security Device Manager, and we used SDM to secure our router by applying several different Cisco recommended best practices to that router. First of all, we telnetted to the router. We took a look at the existing configuration prior to our lockdown. Then we went into SDM and we initiated the one-step lockdown process, which applied several different Cisco recommended best practices to secure the router. After we did that, we attempted to connect via telnet once again to the router, but we discovered something very interesting. The telnet connection that had worked previously was denied this time. The reason being that telnet is not a secure protocol. Telnet does not encrypt traffic as it travels across the network. Therefore, if an attacker were to capture those telnet packets, they might be able to gather information about the network, such as password information. However, we were able to successfully connect using a secure shell application. It was called PuTTY. We connected via PuTTY and took a look at the running configuration after the one-step lockdown, and we saw several different security configuration changes, such as the activation of various services, and specifying that the only input transport that would open up a remote connection with this router was secure shell as opposed to telnet. But then we took it a step further. We configured IPS, Cisco's intrusion prevention system. With IPS, we had a database of signatures of well-known attacks, and if the router were to see one of these attacks, it could send us an alert that this attack was occurring. It could drop packets that matched that signature. It could even send a TCP reset message to the source device that was sending us those packets that were matching the signature. And finally, we verified the configuration after running IPS, and we were able to see the individual signatures inside of the internal database. This database was stored inside of Flash inside of the router, and the database of signatures varies depending on how much memory your router has. However, Cisco recommends that we not rely on this internal database. They recommend that we point to an external signature server. And that is going to wrap up ISCW Lab number 3.